Hi guys, welcome. This is the study guide review. Now I already did all the problems, so I'm just going to kind of be talking through them. So let's go ahead and get started. All right, centers are radius ry. You could have picked some other ones. Diameter, there's two, ty and xw. A chord is any endpoint, so uq could be one as long as you wrote it as a segment. Vt diameters are also chords. Central angle comes from the center, so r has to be in the middle of it. So XRY or YRW would be a good example. Let's just zoom in a little bit more, sorry. Major arc has to be over 180, so WXY, so that goes over 180. Minor arc, XY, less than 180 and only uses two letters. The tangent, NM, right here, hits the circle once. Point of tangency would be P. And then the secant is going to be UQ. Hits it twice. We're probably not going to have that on the test. Okay, next one, find the exact circumference and area of the circle below. Well, this is the diameter, so circumference is just pi d, so 35 pi. And then a couple things I'll write in though. So we had to find the radius, so that's going to be 35 divided by 2. And 35 divided by 2 is going to be 17.5, so 17.5. And so for the area, we just had to do pi 17.5 squared. We got 306.5 pi. It's that exact form, so that's why you leave it in terms of pi. Given the circumference of a circle is 18 pi, find the exact of the area. So I just set 18 pi equal to 2 pi r. I divided by 2 pi, so 18 divided by 2 is 9, and the pi is canceled. You get 9 pi, and then we just put in the area form, and we got 81 pi square centimeters. That is page 1 of 6 pages. Oh my gosh. Okay, same thing. They give us the area this time. So I set it equal to the area divided by pi, and then square root of 144, and I got 12. And then we just had to get into the circumference formula, 2 pi times 12, so it gave us 24 pi. All right, the secret to number 5 here, that's an N by the way. The secret to number 4, is to find all the interior angles first. So 27, I knew this was 27 because they're vertical. And then since NJ is a diameter, I did 27 plus 67, subtracted from 180 to get 86. And then I did the same thing on this side, subtracted 27 from 180 to get 153. Once I knew that, it was pretty easy to find the rest. Central angles are congruent to their intercepted arcs. So PN was 86, RJ is 27, MJ was 153, NMP was all of this. So you just add all those together, you get 274. And then NJ is the diameter, so you go either way. They really should have used 3 letters, but you get 180. All right. This one right here, this is a diameter going through it, even though it's kind of got cut off. You can see 3x plus 45. So, oh, I actually set this one up completely wrong. I apologize. Good thing I caught that. I was not even paying attention. So these two are going to add up to 180. So we get 3x plus 45 plus 28x minus 20 equals 180. So sorry about that mistake there. We'll just cover it up like it didn't even happen. And so we'll just combine like terms. We get 28 plus 3 is going to be 31x. 45 minus 20 is going to be plus 25 equals 180. And then subtract 25 from 180, and we're going to get 155. And then divide by 31. And yeah, so 155 divided by 31 is x equals 5. So sorry about that, my bad. And it just asks for x, so nothing tricky about that one. All right, so moving to the next one. I told you to just skip this one because it was hard to read what this answer was over here. So just finding the area of the sector, it's 81 over 360 and then pi r squared. And 14 is yx, so that means the radius are 7. So we use 7 squared. And if you put in your calculator correctly, you should get 34.6 square inches. 2 down, 4 to go. Okay, hopefully no more mistakes, but we'll see. All right, so next, this is when you have that radius coming off here, so we can draw in our own radius. So I drew this yellow line in right there, So I could get a right triangle with a 13 as a hypotenuse and 8 as one of my sides and x is the other side. And using basic Pythagorean theorem, we get the square root of 1 of 5, or about 10.24. All right, this is a chord one. One of our rules states if we have congruent arcs, then we have congruent chords. So we set them equal to each other and got x equals 3. Okay, this is a fun one. Again, we have equidistant chords, so the chords are congruent, which means the arcs are also congruent. So I just wrote the arc in twice and 106. So I said, hey, if I did this plus 106, I should get 360. Just to make it easier, instead of adding 10x minus 23 twice, I just times it by 2. And we ended up with all of this great stuff, and we got x equals 15 here after doing my algebra. I don't even know what numbers these are. They got cut off. This is a B over here. So first thing, AC, we located that AC opens up to that 32. They're inscribed, so you just had to double it, and we got 64. And then BCD is actually the angle in yellow, and it opens up to the arc BD, which is, that says 146, kind of hard to read. And we just had to divide that by 2 to get 73. So that was using inscribed angles, or half of the intercepted arc. Halfway there, oh my gosh, I feel like we've been talking forever. But it went a lot faster because I already had all the work done. All right, so find the value of x and the measure of AD if ABD is 13x minus 27, I put there, and ACD is 6x plus 29. Notice they both open up to the same arc, so I can set them equal to each other and get that value of 8. So I got x equals 8 right there. But then I had to find AD, so to do that I had to plug it back into one of the original angles. So 13 times 8 minus 27, I got 77 degrees for the inscribed angle. And the arc is just going to be double that. So I just doubled it to get 154 degrees. So, fun problem. Next up, remember we have opposite angles add to 180, but this one was even easier. I was just trying to find this arc of BC, but I knew that this angle right here opened up to this entire thing. So I just doubled 76, and I got the value of 152. And as long as I subtracted 52 from it, I should have what's left over, which is 100 degrees. Again, not to scale this picture because it looks like BC is smaller than AB. Last of this page, again, cut off, but V was the angle down here. V, I can't see very well, but this angle opens up to that major arc there. And all you had to do is add 43 and 94 together to get 137. So to find the angle V, we just had to divide it by 2, and that gave us the 68.5 answer over here, and that's in degrees. Okay. All right, home stretch. This is the hardest one I'm about to show you, so don't panic, I hope. This is the area of a segment. So the area of a segment is this general formula. So maybe I should try and hide some of this as we're doing it to make it seem not as scary. But basically what we want to do is we want to find the area of the sector, the area of the triangle, subtract them, and that will give us the area of the segment. So the sector is the easiest piece. 80 degrees right here, so that means the arc's 80 degrees. So we did 86 over 360 times pi 10 squared, and we got this value here for the sector. Again, that's the entire pie-looking shape, okay? So that's this whole pie guy right here, okay? Next, I had to find the area of the triangle, and this one was not for the faint of heart. Since we didn't have a 90 degree here, I had an 80 degree. So I redrew the triangle with an 80, and I put in basically a 90 degree altitude. And so I broke this triangle into a 40, 50, 90, and I used my power of trig so I could find some other lengths. Because I only had one length of 10 in this triangle right here. And so I had H and I had A, so I used cosine of the angle 50 equals A, which I use as X, over 10. So I got 6.4 for this bottom piece. And you saw me write it in here, 6.4, 6.4. So the base of this triangle is 6.4 times 2, which in my calculator I got 12.85. Okay? And then I said, all right, well, I still need to know. So now I figured out the bottom portion, but I need to know the height. And so using 6.4 as the bottom, 10 as the hypotenuse, I used Pythagorean theorem to find 7.6 as the height. So I had 1/2 base 12.85 times the height of 7.6. That's 7.6, not 76. And I got 48.83, subtracted them, and that's how I wind up with the green segment, which is the shaded part. And that is 20.98 square centimeters. Okay. Next one was also quite difficult. I actually found the area of the sector, but the sector I found was actually all of this. Okay, and so kind of looks like a Pac-Man. Nom, 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 nom. And what I did was I said, all right, if this is 120, the rest of this is 360 minus 120, so I got 240 times pi 12 squared is my radius. So I got 301.59 as my sector. For the triangle, it is not an easy one again. So I redrew the triangle with this bottom part as the base. I split the 120 at the top. So we had this angle of 120 right here. I put it right there at the top. I split it 60, 30, 90 with 12 right up here. 12 is in the 2s position. Because 12 is in the 2s position, I could find the s position and the s rad 3 position. So the height was 6, so here's my height. And then we get 6 rad 3, but there's 2 of them because it got split down the middle. So I had to do 6 rad 3 plus 6 rad 3 to give me 12 rad 3. And so half of 6 times 12 rad 3 gave me 36 rad 3 for my triangle. And once I added those together, I got my final answer right here in decimal form. Okay, so those are pretty much the most difficult ones because finding the triangle was not easy. It required a lot of our past work. Here we know that a radius and a tangent line meet at a 90, so we get x, 12, and 15, basic Pythagorean theorem. We get x equals 9. And the final countdown. Okay, again we see a right triangle here. But what's really cool here is we have two tangent lines meeting at external points. That means they're congruent. So if this piece is x, this piece is x, which is really important because that x right there is actually a part of the right triangle. So we could do 8 squared plus x squared equals this whole thing, 8 plus 9, which is 17 squared. We get x equals 15. And last but not least, I went a little overboard on this one. Basically, I kind of just said, hey, let's find more than we need to. So we had the original 8 here, so I found 8 was there. 8 times minus 12 is 4, so that was 4 and that was 4, so part of x was 4. And then over here, I knew 8 was this, so that had to be 7 to make 15, which makes that 7 because they're congruent. Subtract 7 from 16, we get 9, and that's 9. So x was just 4 plus 9, which is 13. But then I also found the perimeter at the same time because I thought, why not? So I added them all up, and I got 56, because you might have to find the perimeter on the quiz. All right, that is all for this segment. Thank you for your time. Extra credit, what should we do? Like, should you draw something? Should you write a word? What should you do? I know. Okay, so go ahead and write your